Okay, so this is homework 2, problem number 5, which wants us to find dr over d theta of theta to the 7/8 plus r to the 7/8, which equals -1. And so we can see that we're going to need to be able to use implicit differentiation. And so basically, to make a long story short, with implicit differentiation, since we know that we're finding the integral in respect to theta, we're going to make we know that the derivative of theta equals, or normally because we're deriving the function with respect to theta, the derivative of theta will be 1, because according to deriving rules, the coefficient equals 1, so therefore the derivative of theta equals 1. But for this function, the derivative of theta will equal 1, but for r, the derivative won't be 1, but rather it will be another variable, r prime. And r prime is simply equal to dr over d theta. And so now if we were to find the derivative of the entire function, we'd have 7/8 times theta, 7, and then theta to the power of 1 minus 7/8, or 7/8 minus 1, which equals -1/8, and then times 1, which would be the derivative of theta. And then we have 7/8 times r to the -1/8 times the derivative of r, which in this case is r prime, and this would be equal to 0. And so if we were to go down and then isolate r theta, we'd get 7/8 r to the -1/8 times r theta equals -7/8 of theta to the -1/8 power. And so now we want to find r prime, so we divide by this 7/8 r to the -8, and we get r prime is equal to -7/8 of theta to the -1/8 over 7/8 r to the -1/8. And so we can cancel out the 7/8 here, and we can find that r prime is equal to theta to the -1/8 over -1/8. And because both of these powers are negative, we can just switch them and do the reciprocal and then change the powers to positive. So this would equal negative r to the 1/8 over theta to the 1/8. And then that's your answer.